everyone. We are going to do topic 4, proportional thinking today. We're going to do 4.1 today. So we're going to start by taking a look at proportions. Now, I'm hoping you remember ratios. Proportions are, a proportion is an equation where two ratios or two rates are equal. They're usually written in fraction form, but they don't have to be. So, for example, I could say that the ratio of 2 to 3 is the same as the ratio of 4 to 6, although I probably would write it as a fraction, which would be 2 to 3 equals 4 to 6. So that's a proportion. And if you're thinking, geez, those just look like equivalent fractions, you're not wrong. Okay. The difference is that a couple of differences. One is that you're never going to write a proportion as a mixed number. Okay, so for example, I could turn this proportion upside down and I could say that 3 to 2 is the same as 6 to 4, but I would never say that it's 3 to 2 equals 1.5 when I'm talking about proportions, because 1.5 is not a proportion. Okay, what we're talking about with 6 to 4 is the ratio of 6 to 4. Okay, when two ratios are equal, we say that they're proportional or they're in proportion. And we do have this proportion rule, which basically says that if I multiply these two numbers, it's the same as if I multiplied these two numbers. So A times D equals B times C. If that's true, then the ratios are proportional. And if the ratios are proportional, then A times D equals B times C. So we're going to start with some examples just determining if the ratios are proportional. So for this one, I'm going to say, does 3 times 9 equal 5 times 7? A question mark there. Well, 3 times 9 is 27, and 5 times 7 is 35. Those definitely are not the same, so no, these are not proportional ratios. This is not a proportion. All right, this one, 6 times 6, does that equal 4 times 9? So that's 36, and that's 36, so yes, these are proportional. Now this last one is written a little bit differently, so let's write it the way we've been seeing it, write it as if, so it looks like fractions. So this is going to be 15 over 6. The first number is always going to be the top number, and the second one is always going to be in the bottom. So does this equal 20 to 8? Well, 15 times 8, does that equal 6 times 20? And 15 times 8 is 120. And 6 times 20 is also 120. So yes, this is a proportion. All right. There's a quick, just 6 questions where you're going to check to see if these are proportional. So go ahead and do that and then come back to the video. Okay, so now we know how to see if something is a proportion. Now we're going to figure out how to solve a proportion. And when we solve a proportion, that means that I've been given 3 of the values and I need to find the 4th. And there are at least 3 different ways to do it. I'll show you all 3 of them just so you have at least seen them all, okay? So the first one is treat them like equivalent fractions. So if I have 2 over 5 equals something over 40, if I'm thinking about this as equivalent fractions, I would say to myself, well, I have to go 5 times 8 to get 40. So I need to go 2 times 8 up here. So x equals 2 times 8. So x equals 16. Okay, and then if we look at example B, 3 times, I don't know, what do you multiply 3 by to get 10? So, I mean, I could figure it out, but this is hard. This is not actually a good question for equivalent fractions because C is actually going to be a decimal. So um, it doesn't work well in this situation. Let's look at algebra as a method. So in this one, I'm going to do this the long way. I could do it in fewer steps, but I want to show you how it's going to work. Um, I need to get rid of what's in the denominator. So I'm going to multiply, I want to get rid of this one first. So I'm going to multiply this side by 5 and multiply the other side by 5. These fives cancel. And I have 2 equals 5x over 40. And now I want to get rid of the 40, so I'm going to multiply both sides by 40. And now I have 80 equals 5x. So now I'm going to divide both sides by 5. And I end up with 16 equals x. Okay, which, hooray, is the same answer we got before. All right. Now I'm going to do this with example B. So I'll just do the same thing. I'm going to multiply both sides by C. So I end up with 3 equals 10C divided by 7. And then I'm going to multiply both sides by 7 to get rid of the 7 that's in the denominator. And now I have 21 equals 10C. And then I need to divide both sides by 10 to get rid of that. And I end up with 2.1 equals C. All right. That was kind of long and tedious. There's actually a much quicker way to do it, and that is cross multiply and divide, which we're doing before with our percent questions, right? So when I cross multiply and divide, the saying is multiply the pair and divide the spare. Divide by the spare. Okay, so I'm multiplying the two numbers that are diagonal across the equal sign wherever those are, okay? So x equals 2 times 40 divided by 5. So x equals, ta-da, 16, okay? And in this one, c equals 3 times 7 divided by 10. So c equals 2.1. Okay, that is the easiest way to do it. Now, why does cross multiply and divide work? It's actually a shortcut for all of the algebra, the two-step algebra that we did up top here. If you look up here in this example A, we multiplied, we ended up with, on this line, we've got 2 times 40, and then we divided by 5. If you're not seeing that, don't worry about it. It'll actually come up again later in an algebra section, so don't worry about it. For now, it just works, but you have to remember it only works when you have one fraction equaling another fraction. So basically, it only works with proportions, okay? Okay, I was actually going to change this page. Darn. Because the way I'm going to have you solve this one now is actually just using the cross multiply and divide, not using the proportion rule, because your algebra skills aren't there yet. I haven't shown you what to do with that, but we can do this just using proportions. The thing is that this is what we're trying to solve for. Okay, so what my equation is going to be here is y plus 3 equals 72 times 1 divided by 3. Okay, so y plus 3 equals 24. All right, now you need to use your algebra skills to subtract 3 on that side and subtract 3 over here, and you're going to get y equals 21. All right. Now, we haven't talked about how to check proportions at this point, but what it is like if this is think about this as a fraction and this is a fraction, they have to be equal. So that means that if I have 21 plus 3 over 72, which is the same as 21 plus 3 in brackets divided by 72, which is 24 divided by 72, which is 0.3 repeating, that needs to equal 1 over 3, or 1 divided by 3, which is 0.3 repeating. So basically, if you divide both of your fractions, they need to be equal, okay? And that's how you check your answer. All right, let's solve this one. So I've got x minus 0.1 equals 5.5 times 9.4 divided by 2.3. So x minus 0.1 equals, oh, this is an ugly number. It comes out to 22.4782687. Now, I certainly don't need all of those digits in my answer, but I do need to keep them all while I finish my calculations, okay? And so what that means is I might not write down all those numbers, but I'm going to keep them in my calculator because I don't need to clear my calculator right now. I always wait until I need to clear the calculator before I clear what's in the calculator. Because if I look at this and I can see that what I need to do next is add 0.1 to the left side and add 0.1 to the right side. Well, on the left side, I have x, and on the right side, I already have this 22.478 blah blah. In my calculator, I just need to hit plus 0.01, and I get 22.578 ... which I'm then going to round to 22.6. A good rule of thumb is to round it to the same number of digits as your question has, okay? But I would not mark that wrong if you rounded it to 2 digits, or 2 decimal places or whatever, as long as you've rounded it correctly wherever you have rounded it, okay? All right, your turn. Pause the video, you go ahead and do this question and then check your answer. Okay, now we have k minus 7.5 equals 6.9 times 2.1 divided by 5.8. So k minus 7.5 equals 2.498 something something something. And I need to add 7.5 on the left and add 7.5 on the right. And I get k equals 9.998 something or other. And I'm going to round that to 1 decimal place because that's what my question is rounded to. So I'm going to round that to 10.0. Okay, so hopefully you got that right. That is it for this lesson. And, oh, it's not, sorry. Okay, hopefully you got that right. And there's some questions here to practice, and then there's a couple of examples on word problems. So I'm going to go ahead and do the word problems with you. Okay. The key to solving word problems with proportions is making sure that you've set up the right proportion, okay? And there's more than one way to set up any given proportion. All of these proportions that I have written here are actually, they're all valid representations of the same proportions. What matters is that the numbers that are on a line horizontally here are connected in some way. And the one, so like here's 34 and 51, here's 34 and 51, 34 and 51, 34 and 51. They're always together in some way. And then the other two here, 15 and 10, 15 and 10, 15 and 10. Okay, but you also need to have whatever they are up and down are also always connected together. So 34 and 10, 34 and 10, 34 and 10, 34 and 10. Okay, they always have to be together. And usually, um, well, what I suggest is that you have a consistent strategy for where you're going to put the information. And this is the way I recommend because this works in every situation. Okay, so the first ratio here is what I call the recipe. So this is the original drawing, or this is the original recipe, or the scale that you're given, or whatever it is. The reality is what's happening in the real world. So maybe the recipe is a recipe for soup, okay? And then the reality is, okay, how much soup are you actually making if you're changing the recipe? So this is what you're actually doing, okay? And then the top line is one property, and it could be, for example, how much broth is going in your soup. And then the other property might be how much rice is going in your soup. So the broth has to be on one line and the rice has to be on a different line, but both rice measurements need to be on the same line. Okay. When things have different units, that makes it really easy. You would put one unit on the top line and the other unit on the bottom line. Okay. The key to successfully setting up your proportion is to use words, okay, or at least letters. It makes life so much easier. Okay, let's do an example. A boat can travel 80 kilometers on 20 liters of gasoline. How far can it travel on 106 liters? So the two things that we're measuring in this question is kilometers, which is distance, and gasoline in liters. So I'm going to put over here, I'm going to put distance is one of the things I'm measuring, and that's in kilometers. And I'm measuring gas, and that's in liters. And now I'm going to fill in my numbers. So I'm going to start with my recipe, which is what I've been told works. So 80 kilometers takes 20 liters of gasoline. So I'm going to put the 80 here, and I can put the units there. I don't strictly have to, but it's not a bad idea. And then I have 20 liters of gas because those two things go together, right? And then I'm told I've got 106 liters, so that has to go on the liters line. So this is 106 liters. And I'm asked to find how far can it travel. Okay? That's that, but can you see how much easier that was because I wrote these words? Or I might just put a D and a G, or I might just put the kilometers and liters, but I've put something over here. So I've said where I need to put everything. And this is definitely a be smart about your lazy situation. It's so much easier if you just write it down, I promise you. All right. So now I need to solve this proportion. I have x equals 80 times 106 divided by 20. X equals 424 kilometers. And I know it's going to be kilometers because that's the units that belong to the space that's missing. Okay, and then I could check my answer. 80 divided by 20 equals 4, and 424 divided by 106 also equals 4. So my proportion, it is a proportion, my ratios are equal. All right, another example. Sarah enlarged the size of a rectangle to a height of 16.2 inches. What is the new width if it was originally 2.7 inches tall and 1.8 inches wide? Well, this time all my units are the same. It's all in inches, but I'm talking about how wide my rectangle is and how tall my rectangle is. So I'm going to make those my words. And then I set up my proportion with my line equals line, okay? And my recipe is the original. So my recipe is, it was 2.7 inches tall, so I'm going to put 2.7 here, and it was 1.8 wide. And then I've got 16.2 as the height, so that's how tall it was. That's going to go here, 16.2. And I'm going to use a W for my variable here because I'm looking for a width. So W equals 1.8 times 16.2 divided by 2.7. Get my calculator out. My width is 10.8 inches. Is that a reasonable number? Yeah, I think so. Okay, and then I could calculate it. I could do the calculation, the checking. Actually, let's do that. So do that in a different color. Okay, 1.8 divided by 2.7 should be, yeah, 0.6 repeating. And 10.8 divided by 16.2, oops. 0.6 repeating. Now sometimes these will not be exactly the same because you've rounded. If you have to round your answer, they won't be exactly the same, but they'll be very, very close, and that'll be a situation where you're making a judgment call on, is this answer right? All right. Okay, your turn. You go ahead and do this question, and then come back and check your answer. Okay, so we're talking about milligrams of penicillin and kilograms of child. All right, so my recipe says a 21 kilogram child should take 120 milligrams of penicillin. And I had decided that my milligrams is going to go in the top. So that's where I'm going to put my milligrams, 120 milligrams, and my kilograms are going to go in the bottom. It doesn't matter which is the top and the bottom as long as it's the same all the way across, okay? You'll get the same answer. How much penicillin should a 28 kilogram child take? So my 28 kilogram child goes on the kilogram line, and my P for penicillin goes here. So P equals 28 times 120 divided by 21, and P equals 160 milligrams. Okay? Okay, there is a different kind of proportion question, which is a little bit, I don't know if it's, I guess it's a little bit more work, but it's still a proportion situation. For example, 80 M&Ms will be divided between two children in the ratio of 2 to 3. Now, I don't know why you would do that, because you're just going to cause a fight, but we're going to go with it. So that means that one kid's going to get 2, the other kid's going to get 3, and then one kid's going to get 2, and one kid's going to get 3. One kid's going to get 2, and the other kid's going to get 3, until all the M&Ms are gone. So you could do it, let's say kid A on the top and kid B on the bottom. So kid A gets 2, kid B gets 3, kid A gets 4, this one gets 6, this one gets 9, this one gets, sorry, 2, 4, that was supposed to be a 6. This one gets 6, this one gets 9, okay? But that's going to get really tedious long before we get up to 80 M&Ms. But if you notice, this number is always 2 times something, and the other kid is getting 3 times something. I don't know what the something is yet, but the first kid's always going to get 2 times that number, and the second kid is always going to get 3 times that number. And what I know is that the total number of M&Ms, or 2x plus 3x, has to equal 80 M&Ms. Okay, so if I have 2x's here and I have 3x's here, I have 5x's, right? So that equals 80. And then I can use my hotshot algebra skills to divide both sides by 5. And I find that x equals 16. Am I done? No, because that's not how many M&Ms anybody's getting. What it is that kid A is getting kid A is going to get 16 times 2, which is 32 M&Ms, and kid B is going to get 16 times 3, which is 48 M&Ms. Okay, so that's my answer here. Okay, and then I should just check if I add them up, that should equal 80, and it does. So awesome. Okay, make sure you do some of the practice questions that have this, and make sure you do at least one of them that's got a decimal in it somewhere. Okay. Okay, I just want to put an example in here of something that proportion doesn't work for. Okay. For example, if I'm 12 years old and my sister's twice my age, how old will I be when she's 78? So if we set this up as a proportion where here's me and here's my sister, and I'm 12 and my sister is twice as old as I am, that means that she's 24, right? And I'm wondering how old will I be when she's 78? If I solve that, let's make that an A instead of a question mark for age, equals 12 times 78 divided by 24, which is 36. Dims, does that make sense? No, it doesn't. I'm not going to be 36 when she's 78. What happens with ages? We both age at the same rate, right? So they're not. It's not a changing proportionally. It's changing in what we call absolute terms. So the correct way of doing this is going to be now I'm 12 and my sister is 24, and there's a minus 12 relationship here, right? So I'm always going to be 12 years younger than my sister, right? That's never going to change. So when my sister is 72, I'm going to subtract 12 from that. So I'm going to be 60 when, oops, not 16. That doesn't work. I'm going to be 60 when my sister is 72 because I'll always be 12 years younger than she is. Okay? All right. Go ahead and do the practice questions for this. I will be back with 4.2 in a different video. Have a great day. Bye.